Hi students, I am Rajil. Welcome to the new section of metallurgy. Zone refining. Zone refining is used for purifying semiconductors like boron, germanium, silicon, gallium and indium. Principle. It is based on the principle that impurities are more soluble in the melt than in the solid state of the metal. In this method, impure metal is taken in the form of a rod and is heated with the help of a circular heater at one end. So, place the circular heater at one end of the rod. When we place the circular heater at this end become melt. And after that, move the circular heater near to the move the circular heater to the next place X. This place. Can you see here in picture? See my pointer. Okay, and move to the circular heater to the point X. When we move the circular heater to the point X, the point X become melt, and one more thing, impurity from the end will move to the point X because impurities have more attraction towards melt according to zone refining principle. At the same time, the end become changed to solid because due to the loss of heat, the end become changed to solid. And now X is melted and impurities are in X. And move the circular heater again forward to the next point Y. Now you can see in the picture circular heater in point Y. And now the area near to Y become melt, and one more thing, the impurity from the area X will move towards Y. Clear? Impurities present in the area X will move towards Y. Now impurities are in the area Y, and the same time the remaining area including the end and X change to solid because heater is not near to this area and heater is already left from this area. So due to the cooling effect, this area becomes solid. And after this, from the point Y, move the circular heater again forward to the next point. And what happened to the next point? And that point become melt. And impurity from the Y will move to this point. And during that time, other areas like X, Y, and other areas become solid. Like this, move the heater from left to right and up to the point Z. When the heater reaches the point Z, all the impurities from this end to from the middle from this end will reach to the point X. Finally, we can collect all the impurities at the point Z, and this point or this area can be cut off. Then we can remove the impurities from the impure rod. If you want to get more purity, again take the circular heater and start from this end X and move again to Z. Like that, repeat the process, we will get the metal with the ultra purity. And this whole process called zone refining. From the name it is clear why it is called zone refining. The purification by dividing the metal into different zones. Vapor phase refining. Vapor phase refining is used for the purification of nickel, zirconium and titanium. Vapor phase refining mainly divided into two processes, Mond's process and Van Arkel method. Mond's process is used for refining of nickel. In this method, impure nickel is heated with carbon monoxide at a temperature 330 to 350 Kelvin form nickel tetracarbonyl. Nickel tetracarbonyl is a volatile complex, and this complex on further heating at 450 to 470 Kelvin form pure nickel plus carbon monoxide, and all the volatile impurities removed from the nickel, and we will get a pure nickel from impure nickel during this process. Next is Van Arkel method. Van Arkel method is a kind of vapor phase refining, is used for refining of zirconium and titanium. In this method, zirconium treated with iodine and heated to form zirconium tetraiodide, and zirconium tetraiodide on further heating changed to zirconium and I2, and here the zirconium formed is pure, and all the volatile impurities and iodine will remove after heating. So these two processes are used for purification of nickel, zirconium and titanium metals. And the last and final purification technique is chromatographic method. About chromatography, I think you learned from class 11th, so it's just a continuation of that. What is meant by term chromatography? Chromatography is a process of isolation, separation and purification of colored substance mostly. Nowadays, even colorless substances are separated by chromatography. So, chromatography can used for separation as well as for purification. At this picture it is very clear. A mixture of compounds are taken in a chromatography column, and after the process the components of mixture can be separated. Even colored or colorless can be separated by using chromatographic method. Principle of chromatography. It is based on the principle that different components of mixture are differently adsorbed on an adsorbent. Now we will see the process, and mainly we are using column chromatography for the separation and purification of impure metal. In this method, first take mixture of compounds containing different components, different colored or colorless components, and take this mixture and transfer into a chromatographic column. And the chromatographic column is just like a burette, and the inner side of the chromatographic column is pasted with a chemical called adsorbent. And the main adsorbent, one of the example for adsorbent is alumina, Al2O3, and interior of the column pasted with the adsorbent, and this adsorbent is also called stationary phase because it is immobile phase, so it is called stationary phase. When we transfer the mixture of compound, some of the components of the mixture will adsorb more on the adsorbent. And here Al2O3 act as a adsorbent. It adsorbs some of the components more, and that component we can see on the top of the column. A least adsorbed component can see in bottom of the column. Adsorption means it can adsorb on its surface, and the material will not enter into the bulk of stationary phase. It only adsorb on its surface. Like that, after transferring mixture of compounds containing different components will adsorb in different rate, and the component which adsorb more can find on the top of the column, and the component which adsorb least on adsorbent or on stationary phase will find in the bottom of the column. Now the separation over different components are separated according to the adsorption rate, and after that, for removing this adsorbed component, add a chemical called eluent. When we add a suitable eluent, suitable chemical substance, and that chemical substance will elute each component one by one to the beaker. And when the eluent moves down, and the least adsorbed component will come first, then the most adsorbed component. Like that you can separate the components of the mixture separately. Okay, and one more chemical substance we have to use in the beginning for mixing the components of mixture. For example, two components are there. To mix it we need a solvent, so there also you need a suitable solvent. What criterion is followed for the selection of the stationary phase in chromatography? And what do you mean by stationary phase? Stationary phase is also called an adsorbent, and the stationary phase is a chemical and it pasted inside the chromatography column. And the main purpose of stationary phase is adsorb different component of mixture in different rate, and some component will adsorb more, and that component will found on the top of the column. And some cases stationary phases will adsorb some component very less, and that component of the mixture found in the bottom side of column. Like this, stationary phase will adsorb different component of mixture in different rate. Now we will see the conditions required or conditions needed to select a suitable stationary phase in chromatography. The stationary phase should be immobile as well as immiscible with the solvent used as eluent. Immobile means the movement is restricted. Stationary phase should not move. Okay, suppose if it move, what will happen? The stationary phase, when we pass eluent, eluent is a chemical used for separating the adsorbed component from the column. So when we pass eluent, if stationary phase is moving, what will happen? The stationary phase will mix with the eluent, and along with the eluent you will get stationary phase in the beaker. So to restrict this, the stationary phase should be immobile as well as immiscible with the solvent used as eluent. The stationary phase is selected in such a way that impurities are more strongly adsorbed on the stationary phase than element to be purified. Means, suppose if we take impure element actually in metallurgy, why we are using chromatography? For refining impure metal. Then impure metal contain impurity and pure metal. So what is the condition here? The stationary phase should adsorb impurity more than the element. So what will happen? Impurity will adsorb more, so impurity will come on the top of the column, and element will come in the bottom side of the column. Okay, so impure element, the stationary phase should adsorb impurity more than the element. So impurity will separate easily from the pure element, and impurity will come on the top and element will come bottom side of the column. So when the column is extracted with the eluent, the impurities are retained and the pure element is eluted. Clear? When we use eluent, okay, after stationary phase adsorbed impure element in different rate, impurity on top and the pure element down. And after that use eluent. Eluent is another chemical substance. Okay, chemical substance. Then when we pass eluent, what will happen? Eluent will move along the side of column. Eluent is a flowing chemical liquid, so it will flow along the side of column. Then, and the least component of the impure element, which is the least component of impure element, the pure element, will come first in the beaker. And the most adsorbed component of impure element, which is the most adsorbed component of impure element, impurity will in the top, so eluent will take more time to elute this impurity to the beaker, so impurity will retain in the column and the element can be easily eluted. And one of the best example satisfying all this condition is Al2O3. So Al2O3 is used as a stationary phase in column chromatography. Al2O3 is immobile as well as immiscible with this eluent. And one more thing, Al2O3 adsorb impurity more than the element. So we can use Al2O3 as the best adsorbent or stationary phase in column chromatography for purifying impure metal. I hope you understood this chromatographic technique. Okay, here the end of the chapter. Thank you. Dear students, I hope you all understood the complete sections of metallurgy. To get all the videos of metallurgy, subscribe my YouTube channel and enable bell icon. Thank you for watching.